One of the things about quantum computing that doesn't make it very approachable is it's not very easy to understand what it is. Every explanation I've seen of quantum computing starts getting into qubits and how the machines work, and you don't really need to know any of that to understand that quantum computing is not a replacement for classical computing. You're never going to have a quantum computer inside your phone. You're never really going to need one, right? This is just another way to solve really hard problems. Again, I often compare it to like a supercomputer, something you would handle a very difficult task, and it has to be a specific kind of task. You're not going to have a quantum computer do any kind of math for you. The result you're going to get back is always going to be a probability between 0 and 1. So if you're asking a question of how likely is this thing to happen, that's a good question for a quantum computer. So it's a very specialized type of computing that's never going to replace classical computing. It's always going to be like an extra coprocessor sitting next to a supercomputer, and it's not magic. Like we have a lot of problems with it. We don't know if Q day is ever going to come. Q day being the day that it can break encryption, because it's just not very sophisticated at this point. It can't do error correction. We don't have a lot of qubits. Some have said we need 1 million qubits or more before we can even think about breaking encryption. And we're at about 1,000 right now, the most sophisticated machines out there. So it's still very much on the fence whether or not quantum computing is even going to be all that useful.